Hello there, makers, hackers, programmers, musicians? Hopefully. Anyway, whatever you want to call yourself, I have a new library for you today. In case you may have noticed, I put out a video just the other day to go over a new library I created for CircuitPython called Synth keyboard. And that was used as like a helper tool for like managing notes and priorities with voices and arpeggiators and sequencers and stuff like that. Well, this is kind of in the same vein. It's a little simpler, but it's still very useful. This new library I have is called SynthWaveform. I know, not super creative, but it gets the job done. And its whole purpose is to help you generate waveforms to then take wherever you want to put them. In most cases, use them with synthio, right? Since that's the primary synth engine built into CircuitPython. Very powerful stuff. I recommend looking into it. And also, if you're not familiar with CircuitPython, it is a firmware for your microcontrollers. Think of things like the Pico, ESP32, etc. In order to program Python, which is normally associated with desktop, big computers. Well, you can take that really cool, fun, easy to use language and move it to microcontrollers and start controlling physical things and iterating on your projects really easily and testing things. Anyway, I find it to be really useful and a pretty cool tool. And anyway, I digress. That could be a whole nother video. But let's talk about our library. So I'm still working on documentation. It probably won't be live yet by the time this video goes out, but it shouldn't take me too long. It's pretty easy. The actual library itself is pretty easy to use, so I'll go over it regardless. But in the future, you'll see that documentation come out, and I'll update this video description with it. So let's do some tests to start out with. Let's go over to our screen capture. Here we go. And yes, I'm using a widescreen. That's why there's gaps and stuff. Can I make this bigger? Probably. Yes. Is that too big? Let's do 22. Okay, here we go. So, ignore the copyright stuff, whatever. I've just copied this from the library. So we're using NumPy here, and that's kind of the engine that runs this thing. It's a mathematics library specifically designed for it to performing math on list quickly. Because in Python, and CircuitPython is great, but if you're iterating through 10,000 things and performing calculations on all of them, it can get a little slow. So this helper library, it's kind of designed to speed that up by doing a lot of that calculation on bare metal, right? Closer to the microcontroller itself. Anyway, in this case, we're using it here, but we're only using it here to change the data type. If you're just using this library for synthio, you don't actually need to touch NumPy or anything. You can just import SynthWaveform and leave out the D type. The D type, or data type, defaults to numpy.int16, 16-bit integers, which is typically what's used within synthio. Correct me if I'm wrong, but that should be it. Also, size, you can kind of leave that out. The default size is 256 samples, and of course, a sample like an int16 is going to take up 2 bytes, so that 256 is more going to be like 512 bytes of memory, which shouldn't be too much. You can make that a lot bigger. You can make it, 10 kilobytes or something. That might get in the territory like, oh, you might be using up a little bit too much memory here, depending on what microcontroller you're using. Also, it's diminishing returns in a way. synthio is pretty good on each sample. I'm pretty sure it interpolates between them to some degree. Yeah, I'm pretty sure it does. And so you can use, especially if you're doing like a triangle way, you can use a really small, sample size and be able to get relatively accurate results with synthio. The only place it kind of becomes important is with like sine waves, because sine waves need to be really smooth, or like, just really advanced waves if you're like combining a bunch of stuff, or noise or something like that. In this case, this is just for demonstration purposes. I'm doing 8. The default's 256. I think I've already said that, which I think is fine for most purposes. Yeah, just something to be aware of. This will be outlined in documentation. So we're going through all the waveforms we have available. Now this is going to seem pretty basic, but there's actually a lot you can do with these, right? So we have sine, sinusoidal wave, right? Maybe I need to draw this out for y'all. But if you're familiar with synthesizers, you know what a sine wave is, right? And also, if you want a cosine wave or something like that, really cosine is just a shifted form of sine. There is an option within this to set the phase, right? And that's a value from 0 to 1. 1 being an entire shifted, like the phase is like the shift of the waveform. 1 would be an entire shift of the waveform over, so it'd be the same data pretty much in this case, because we're only doing a single sine wave. But if you wanted to shift it half, I think a quarter wave for cosine, it's either a quarter or a half of the way. Now we could be talking about radians. I'm not talking about radians or degrees here. It's just a value between 0 and 1, even though you can go beyond that for this phase. It could be anything, but 1 is a single waveform, right? So you do something like that and you get a cosine wave. We're not really doing that because it's not really necessary musically. So we're just going to leave it for now. I will mention there is a frequency parameter that you can set. And you can do like 2.0. By default, it's 1.0. It's a float number. But if you set 2.0, it's going to give you 2 waveforms in that single buffer, right? So if you put this as a frequency of 1 and you put the sine wave into synthio and you played an A4 note, I believe that's 440 hertz, it would come out as a 440 hertz sine wave. If you put a frequency of 2.0, it would actually generate an 880 hertz sine wave. So that would be A5, I believe. That seems kind of weird. Like, why would you do that? But you can do some weird stuff. Like, I could do 1.5, and then you would get. I need to draw. I need to draw, y'all. New, sure. Okay. This is on the fly. I apologize. So if I did 1.5, oh, that's a big brush. Here we go. Boom. You would get like that, and then it would repeat again. Point being, that could be kind of cool, right? You could maybe get some weird effects with that, and you'll see this. Oh, I messed that one up. Whatever. A lot of the synthesis here, a lot of the waveforms have these settings in them. There's one other setting, which I'll show you this in person later. There's one other setting to talk about, which is amplitude, right? By default, 1.0, which is just, if we're talking about, in this case, we're doing floats, and floats, because I have this np.float set. Floats by default, for synth purposes, will go from -1 to 1, and 0 being kind of the midpoint, your mid-level. If I bring amplitude down to 0.5, it will obviously reduce this down on that midpoint. And if I set it to 2.0, there's actually some clipping built into the system, so it'll go up, which I should clean this, but let's do it like this, and let's say this is the top and this is the bottom. It'll go up, hit a hardline clip, and then come down and do the clip on the other side too, so you can maybe get some cool hard sine wave effects. I don't know, you can do some cool stuff. There's no like fancy distortion or soft clipping. That would be cool, but we're not doing that right now. Anyway, so you can do that for all of these. Now, some of them, like, sine and triangle have those 3 parameters. Saw has an additional parameter, which is reverse. By default, it's false. We don't want to be reversed by default, but if you set it to true, it'll appear a little differently. So which I should just clear this sucker, shouldn't I? Or maybe it'd be better just doing it. Boom. Okay. So with a normal sine wave, or sawtooth, I'm sorry, you get like this pattern, right? When it's set to reverse, you'll get this pattern. Just reverse the direction. Now, this is Boolean, binary, right? It's just either on or off to switch the way that's calculated. I kind of tried to look in a way to make that more fluid, so you could set it as 0.5, 0.75, but I couldn't really figure out how best to manage that. But if anyone has any ideas there to like give you more options, that'd be really cool. Now, the other one is square waves. Now, square waves have duty cycle, which by default, it's 0.5. If you're familiar with PWM at all, you'll know what duty cycle is, right? It is, by default, your square wave is just going to be cut in half, right? And that's the duty cycle of 0.5. Now, if we had a duty cycle of 0.25, it would be a quarter on and then 3/4 off, and then that would be repeating, right? And then opposite, if you did 0.75, sorry, I cannot type with a mouse. It would be 75% on, quarter off, repeating, right? And obviously, you can get some weird stuff. Now, there's a bit of an issue. When you're generating these waveforms, you know, it has to take up some processing power to create the buffer, fill the buffer, and do the other processing on it and give you that waveform. Let's say you had an LFO, which is low frequency oscillator. It's pretty much something that goes up and down, like one of these guys, and but at a slower rate, you know, 2 times per second, 1 time per second, whatever. If you fed that into this to control the duty cycle, which would be cool, like that'd be super cool. You can get some really cool sounds out of that are unique. You'd have to regenerate that buffer every time. Currently, there isn't any garbage collection going on here. It's kind of relying on CircuitPython to do that, or for you to do that, because it just gives you the reference to the array for you to manipulate, right? I don't know. There's probably better ways to calculate that duty cycle rather than regenerating the square wave every single time. Correct me if I'm wrong. You know, if you play around with this and you're like, oh yeah, it works great for that, then awesome. That's what I hope is the case, at least. But otherwise, you may incur some issues. Anyway, okay, last one, noise. Now, noise, I don't believe has, you know, frequency, you know, because it's just noise. It's just random. White noise in this case. I didn't do pink noise or anything. I don't know how to do that per se. I probably should look it up. But noise will just give you random values, right? You can't do phase or frequency. It just doesn't really work. But you can still do amplitude. And so you could, if you crank that amplitude up, you could get some like really harsh distortion kind of noise. That'd be interesting. Probably bad. But or you could bring it down a lot and get like subtle noise. Now, of course, you can control it within synthio or something like that. I can't really draw a noise waveform. It would just be noise, right? Something like that. We'll move on. Now, mix. Now, this is where it gets fun. This is where I think you could do some really cool stuff. If you want to make, you know, synthio is limited to 12 notes at a time, I believe. And let's say you want to get the most out of those 12 notes as possible, right? You want to make them sound really funky. You could generate a really cool waveform here. So, like, let's say you had sine, and then you have noise, right? Which I think is what we're doing here, actually. Yeah, we have a sine wave, and we're joining it with a noise wave, but you'll notice I have this in a tuple. Well, a tuple's like an array, but it's like a static array. It can't be changed once it's created. And the second value is a float of 0.5. So it's actually that's like a level for the noise. Now, of course, I could do this as amplitude, 0.5. That probably have similar results. But, you know, this allows you to maybe reuse that noise wave or something like that, whatever. Anyway, you can change the level so I can have a lesser noise. And all of a sudden, we have that sine wave, but it's kind of a messy, noisy sine wave, right? And we'll see that later. So that's kind of cool. And you can combine as many as you want. You know, it's all comma separated. It's variable arguments, right? I could just do another SynthWaveform.saw. I'm not going to add the parameters. And I can put this in a tuple and make it 0.25. And then that would do something weird. I'd have to think about it. It would be like, when sawtooth starts, yeah, I didn't reverse it. So it's going to start high, and then it's going to go low. It's going to do that, and so it would make a jump or something. So it sound kind of square wavy, I think. Correct me if I'm wrong. But yeah, you can do some weird stuff using this mix function, and you can add as many as you want. Another great use, I think, would be to do a sawtooth, like a super saw thing, like combine like a bunch of sawtooth waves, like different octaves and stuff into one waveform. I think that'd be really cool. In fact, you could like get. I digress. You could go in and on and on about this. I'm not gonna. I'm gonna save y'all that trouble. Okay, the last one. This is just kind of a helper tool. You can generate, like, let's say, I don't know. You get a waveform from like a classic synth. You know, hey, here's the square wave of a mini Moog or something, and you save that as a 16-bit wave file. This will take that in. It doesn't necessarily interpolate it to the size you want. I think it just hard clips it. I probably should get it to interpolate, but you can set the max size that you would like of it, and it'll just convert that into an array for you to use with your synthesizer. Synthio, yeah, cool. So that's just a helper function, and you can use this data with mix as well. I don't think there's a lot more to this. I'd have to look it up, but this is kind of simple at the moment. I might expand upon this in the future. Let's run this, make sure it works. I already have this library installed. The easiest way, because it's not on the community bundle of CircuitPython yet, the easiest way to do it is just to copy the .py file, or I'll probably compile a .mpy file for you to bring and copy into the lib folder of your thing. So here's CircuitPython, right? It'd be lib folder, and then you see here I got SynthWaveform, right? I got some other stuff too. In fact, this does rely on Adafruit Wave, so you have to install that as well. That'll be in the documentation on how to do that. Okay, so we run this, and all this does is just gives a bunch of arrays. I don't know if y'all can see that too well, but you can kind of see they're pretty short, only 8 samples, so you can kind of see how the waveforms work there. You can play around with it as you want. That's a simple test. We'll move on to the next thing. This is how you actually plug it into Synthio. Very simple. You provide your node. I'm setting it as A4, just default for now. And then you set the waveform to be the sine wave generated by SynthWaveform. Boom, done. Now here, you want to make sure the D type, I think, should be int 16. So if you wrote it out, it'd be like np.int 16. I'm not importing numpy on here, so you'd have to import numpy or numpy. But that is generally what it's doing. That's the default. And that'll work right out of the gate. And then here I'm just using PWM out. Your discretion, what you want to do there. Now here's the cool thing. This is what I'm going to show you all today and get a little funky with it. I built just kind of like a waveform manipulator, oscilloscope kind of, that uses this waveform library. And it just displays it on an I2C screen. Let me show you what that looks like. I'm not going to dive into the code here. I had to get a little bit more complicated. But as you can see, I'm just generating those waveforms, changing the amplitude, phase, frequency, duty cycle, etc., depending on what waveform it is and the size and the D type, blah, blah, blah. And then we're just displaying it on the screen. And then we have some update stuff for the controls. I'm not going to get into it. What I am going to do is show y'all how this works. Now I'm using jumper wires, so it's a little messy. Let's go back to the camera, and I'm gonna put you down over here. Okay. This is not gonna be the best camera angle. I'm gonna zoom you in. There you go. Also, this is upside down. Can I flip? Can I flip it? Is that? Can I flip it? Pan? Tilt? Is it tilt? No, it's not tilt. Pan. No, it's not pan. Whatever. You'll have to, this is upside down. And it's a bad video, but it's cool. I promise. You have your I2C display. It's an SSD 1306 module. Simple. Rotary encoder. The wires are terrible, so this might not work that well. But we see we have a sine wave. And the first setting I'm going to adjust is going to be the amplitude. Oh, you see it's changing, and you see how it's clipping like that? Pretty cool. And then I bring it down. You can actually invert the amplitude too. If I do a negative value, so this is going to be close to -1, it flips the sine wave, and then you can still clip it. So that's pretty nice. Now you can alter some other stuff. If I go to the next thing, it should be phase. And you notice how it's moving that waveform around? Okay, sorry, I'm jumping ahead. Now I'm modifying frequency, right? And you'll see how it's adding to the frequency. Sorry, the encoder is terrible. Here we go. And then the fourth value doesn't do anything, but I can still do amplitude. And you can change the phase. Now I will say the phase is relative to a single waveform. So if you put a frequency of 80 in there and you do a phase of 1, it'll only jump a single waveform, right? I just thought that was the most appropriate way to do that, so you can fine-tune things while still adjusting the frequency. Okay, let's go to the next one. It's a double click. Cool, triangle wave. Now it keeps all the settings, which is fine. So this is still on phase. We can change, all the same settings. There's no shape parameter on this one. You can still clip it. It'll give you a slightly different sound. You can still invert it, etc. Next thing. Sawtooth. Yep, same deal. This is just a fun way of playing around. The only thing I'll show with this is frequency is you can adjust the direction. Let me go the other way. I did this a weird way. There you go. Boom, reverse. So there's the flip side of it. Right? Boom, boom. Lovely. Next thing. I didn't click it good enough. Demos, am I right? Square wave. Now, all the same parameters, and you'll notice, those 3 parameters, they start to get a little samey, but you need them, right? So here, the one parameter we have different is the duty cycle, right? So I did make a limit on there that you have to at least have 1 sample of a high and 1 sample of low. So you can't generate, just off sync, 0, whatever. It wouldn't all be down low, all down to high if you put a bias of a duty cycle of 0 or duty cycle of 1. There's gonna at least be a little bit of a blip, and I felt that it was important. At least you have some form of waveform in there. And then let's move that. Okay, last but not least, noise. You'll notice here when I adjust this, I can adjust amplitude, but every time I do it, it's gonna regenerate the noise waveform. It's not actually saving it. Pretty cool. Yeah, so like if I change phase frequency, it's just gonna, regenerate it. That's fine. Next thing. Oh no, we're back to the center. Okay, cool. That was it. That was a little oscilloscope, test. You could play around that if you want, just get an idea of how it works. But that's pretty much it. I hope this. Oh, I gotta go back to my face. I hope this is useful to somebody. I know I'm gonna use it for my future synth projects, just to make life easier, not have to think about things too much, and generate some cool waveforms using that mixing and the frequencies and stuff, like getting weird double octave kind of stuff, and really expanding the timbre of synthio, right? If you have any questions, let me know. Like I said, I'm going to update the documentation here in a moment. Have a great day. It's been a pleasure. Bye.